something called, oh, thank you. Periodic functions. Periodic functions. Periodic functions. Draw this for me. I'll make it XY, but make it all the way out here like this. Like this is the X and this is the Y. And I want you to graph for me. This is, let's see, this is, let's see, 1, 2, 3, 4, 6, 7, 8. What am I having you graph? What do those letters mean? What am I about to have you graph? No, it's absolutely something. Look at these letters. I bet you could figure this out if you think about it. Aha, say it again so everybody can hear you. Aha, these are just the months, right? January, February, March, April, May, June, July, August, September, October, November, December. What I'd like you to do right now on your paper is graph this, the y-axis here. I want you to put the temperature. What's the average temperature for each month? So you're guessing, like for instance, what do you think the average temperature is in July in Tennessee?
90s.
Be more specific. Give me a number. What number do you think is the average high temperature in
89.
July? 89. If you think it's 89, then when you get to July, graph 89. If you think it's 92, then graph 92. So just put a dot wherever you think it is, right? We'll say this is 0, and we'll say this is 100. I don't think it once in a while gets over 100, but not very often. So and then do that for the other months. Put a dot where you think the average high temperature for that month is. For instance, most of you thought July, the high temperature was going to be like 88 or 92 or something like that. What do you think the average high is in January in Tennessee? The average high. I'm not talking about how low it gets at night. I mean, the average high during the day in January 42. In Tennessee. What? 42, 45. It's above freezing, but January is pretty cold, right? So I'd say, yeah, 42, somewhere in there. So for January, for instance, if this is 50, then I'd say January is down here somewhere, right? And everybody was saying, let's see, that's June, July. July is way up here, right about 90 somewhere. So that's way up there. What starts happening after July? It keeps hotter and even hotter in August, and then hotter in September, and then hotter in October, and hot. No, it doesn't keep going up, does it? What happens to it eventually? It starts going back down, right? So I want you to just figure out what happened. And then once you get to December, is December warmer or colder than January? Warmer. December. Warmer. I'd say maybe just barely warmer, right? But it's still kind of cold. So when you get all the way over here to December, it's probably pretty close to what January's temperature was. But what's happening between here and there and then back to there? It kind of goes up and then it kind of goes back down, right? Would everybody agree that it kind of goes up and then it goes back down? So I'm going to draw this graph slightly differently. If I kind of compress it here, I'm going to make this 1 year. This is 2 years. This is 3 years. And we're going to go from January to January. Doesn't it start? Let's see, here's 100 again, and here's 50. Oops, not 500, 50. In January, it starts out a little below 50 in the 40s somewhere. And by the end, at the start of the next year, it kind of ends up there, right? But in the middle, like up here in July, doesn't it kind of go up for a while and then it kind of comes back down, right? And then what happens the next year? Does the same thing. It kind of goes up in the summertime and it comes down in the wintertime. And then in the third year, what happens? It goes up in the summertime and it goes down in the wintertime. The temperature follows what we call a periodic function. The period is what you should write down. The period of the function, write this down. It is the length of the smallest interval over which the function repeats. Oh, thank you. So I want you to write that down in your notes. Don't just stare at me. I want you to write this down because I don't want to have to give you an assignment on this where you have to write it all down. I'd rather have you write it all down right now. The period of a function is the length of the smallest interval over which the function repeats. So you tell me, what's the period for temperatures in Tennessee? What's the smallest amount of time over which the entire function repeats itself? What do you think? At the end of the year, 1 year. It looks like the period, once it gets to here, does it start repeating itself? So the period looks like it goes from here to here. This is the period. The period goes from there to there, or from there to there, or from there to there. It's just every time that the pattern repeats itself, that's a period. Here's another word you need to know, the amplitude. Have you ever heard the word amplitude in any other class? In any other context? What? Okay, has there any other class you ever heard about amplitude? In a science class or anything like that? It sounds like altitude, and it has something to do with that. Amplitude, if you ever study electricity, they'll talk about amplitude like amps. Like if you buy a light bulb, it tells you how many watts it is, right? But amps is different than watts. Amplitude is how much power is actually coming through there. Watts is a little bit different. But amplitude is 1/2 the absolute value of the difference between the minimum and the maximum. It's half of the absolute value of the distance between the minimum and maximum. That sounds really, really difficult, but here's all it means. It means it's half of the distance between the top point and the bottom point. What did we decide was the hottest it ever gets in Tennessee on average? Where did we decide? Let's make it easy on ourselves. Let's say this was 90 up here, right? That's the hottest point. And let's make it easy on ourselves. Let's say this point was 50. Just to make it easy, right? So if the 90 is as hot as it ever gets, and 50 is the lowest it ever gets, and how far is it from the top to the bottom? How many degrees? 40. What's half of that? 20. So the amplitude for this one would have an amplitude of 20. If from the top to the bottom is 40, then the amplitude is just half of that distance. That's the amplitude. Last bit of vocabulary you need to know is this, the midline. The midline, take a wild guess. It's the line where? In the middle, exactly. It's the average, it's the line, it's the average of the minimum and the maximum. The average of the minimum and maximum. Well, our minimum was 50 and our maximum was 90. So where would I put the midline? 70? So on my graph here, if I went right about here to 70 and drew a line, doesn't it make sense that that's the middle? It kind of cuts the graph in half. By the way, what do you think 70 represents in the real world as far as temperatures go? The average, right? It's the average temperature in Tennessee for the whole year. Sometimes in the wintertime, it's really cold. Sometimes the summertime is really hot. But right about this time of year, the average is about 70. That's why this is such a nice time of the year, because it's pretty nice out, the average. Because we're right about, where are we in this graph? We're right about here, right? We're right about here, April, May. That's when the weather's really nice. Not too hot, not too cold, right in the middle. So at night, yeah, we're talking about average highs. If we did average lows, the graph would look just like this. It would just be shifted where? Down a little bit. Exactly. Give me another example of something that uses a periodic function. Can you think of anything? What about this? Watch this. If you ever watch TV and they've got, say that again, tides. Do tides follow a periodic function? Yeah, tides come in, tides go out. That's an excellent example. Yes.
So what if it's not the same every?
Good question. What if it looks like this? Oh, I'm really bad at this. What am I trying to draw? I'm trying to draw a heartbeat. Is a heartbeat a periodic function? It is. But all right, like Danielle is saying, it doesn't look exactly the same every time. Now, those of you who are in the health sciences know there's all kinds of different parts of the heartbeat, right? This is when the atria contract, this one, the S, and the amount of distance between the Q and the T, that's called like the QT interval. Do you guys talk about that at all? You're not that advanced. I used to sell drug pressure medications, and the distance between, because whenever they look at this is an EKG, right? So an electrocardiogram, they look at that, but it's this, but this is just one period of it, right? Then it does this again, and it does it again, and it does it again, and it does it again. Anyway, the distance between the Q and the T is very important. Doctors look at all this stuff. Doctors and nurses will look at your EKG, and just by the way it's shaped, they can tell all kinds of things about how well and how efficiently your blood is moving and that kind of thing. But a heart rate is another thing that is definitely a periodic function. Here's something else that's a periodic function. A pendulum. Do any of you have an old grandfather clock in the house? You know what I'm talking about? You got the clock, right? And it's in a great big thing. And then it's got a pendulum, and the pendulum kind of swings back and forth. It goes like this and like this, goes tick tock, right? Okay. What is this? Yo-yo. Those of you who are watching on TV, there it is. Yo-yo. All right, you're not going to be able to see this on TV, but just pretend. All right. Watch. What happened? I'm trying to hypnotize you. What's happening here? Is this periodic? Could I graph what's happening here?
Yeah.
I could. Let's figure this out. All right, let's see here. Clock, stopwatch. Okay, I'm going to start the stopwatch. I want you to count 10 periods. So a period is from here to here, right? Because that's one complete cycle. It goes that way, it goes that way. Think about like this is wintertime, summertime, wintertime, right? Low temperature, high temperature, low temperature. Let's figure out, do you think that the length of a pendulum, the period of the pendulum, what do you think it has to do with? Well, let's try it. I'm going to do 10. And Andrew, I need your help. I need you to hit start when I say go. You ready? Hold on. All right, but the people on TV, you got to see this. I need you to hit start when I say hit start, and I need you to hit stop when I say hit stop. We're going to do 10 of these. Ready? And your mark, get set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. All right. What's the period? Not 19.4. What is the period for what we just did there? We divide by 10. What would this be divided by 10? 1.94. So it took 1.94 seconds for this to go from here back to there, right? All right, what do you think is going to happen if I take the string and make it half as long? Is it going to take less time or more time? How much less? All right, we got to do this for real here. So I'm going to take this ruler here. This was 33 inches. So what's half of 33 inches? How much? Help me out. What's half of 33? How much? Oh, no, half of 33 isn't 26.5. 16.5? That sounds better, right? Doesn't it? Okay, so what I'm going to do is I'm going to grab this thing right here at 16 and a half. Right, that looks about right. That's about half. You ready for this, Andrew? All right, we got to do this again. We're going to reset. All right. Ready? We're doing 10 again. Here we go. Go. One.
I missed.
Oh, Andrew. Andrew. All right, we're going to do this again. Here we go. Ready? Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, it wasn't half the time. The period this time was what, 1.42 seconds? Did the period change though? It did. The period changed. The period definitely changed. By the way, what's the amplitude? We'll do the first one. How would I have to figure out the amplitude? I'd have to figure out how far it is from there to there, right? Let's say that it was this whole thing. If it was this whole thing, this says, let's just pretend it says 39. Let's say it says 40. This is a meter stick, which doesn't convert to inches very good. But let's pretend like it was 40 inches. What's the amplitude? If it's 40 from there to there, then what's the amplitude? 20, right? It's just half. That's all it is. It's just half. Okay, so the amplitude is just half. All right, now, thank you very much, Andrew. Open up your book to page M413. M413. I said we were not going, M413. I said we are not going to have an assignment. There's one more thing that we have to do, however. All right, I want you to be on this page right here. It looks like this. We're going to be, you might want to turn your book sideways so it looks like this. What is the title of our graph here? Underground Ferris wheel. So I want you to stay on this page. I'm going to turn back a few pages and we're going to talk about this. But I don't want you to turn to this page because all you need to know about this problem is right here. But just look up here for a minute. It says one of the most popular amusement rides is the Ferris wheel. One Ferris wheel has a diameter of 50 feet. Riders board the cars at ground level and the wheel moves counterclockwise. Each ride consists of 4 rotations, and you can assume that the Ferris wheel rotates at a constant rate. Okay, you understand what's happened? How many of you have ridden a Ferris wheel? Everybody? At some point you've ridden a Ferris wheel, haven't you? Do they have one here at the Cannon County Fair, or do you got to go like to Wilson County to get? Just a regular old circular Ferris wheel. They did have one here? Okay, cool. So here's what we're going to do. We are going to do an underground Ferris wheel. This one says at a different amusement park, a Ferris wheel is designed so that half of the wheel is actually below ground. Doesn't that sound cool? You go underground, above ground, and so on. So the top of the ride reaches 25 feet above the ground. The bottom of the ride reaches 25 feet below ground. Riders board the cars at ground level. To the right, Ferris wheel moves counterclockwise. So here's what we're going to do. By the way, on this page, the page right before the one you're looking at, do you know what standard position means? We did this a while back. See if we remember. Standard position. This angle right here is in what's called standard position. This is the initial ray. The initial ray goes to how many degrees? 0. This is the terminal ray. The terminal ray, what does terminal mean? That's where something does what? It ends. Like when you're on a flight and you're flying in the airplane, you land at the airport, you then go to the terminal. That's where your flight ends. The terminal ray is where the angle stops. So this angle theta might have an initial ray that looks like this and a terminal ray that looks like that. All right, now I told you all to be on this page. Here we go. We're going to graph the underground Ferris wheel. Here's the Ferris wheel, and it's riding or going around like this. This part is above ground, this part is below ground. So this right here, would you call the initial or the terminal ray? Initial, write that down. That is the initial ray. Then put one up here at about 45 degrees, and we're going to call that one the terminal. I know it's kind of small writing, but you get the idea. Terminal ray. All we're going to do now is graph what happens for how many degrees are we going on this graph? Over 1,000, right? 1,400 degrees. Okay, no problem. We can do that. All right. When you get on the Ferris wheel, how high are you above the ground? What? Ground level. Where is that? Put a dot. Put a dot on 0, 0. So this is what I want you to visualize here. You got ground level, and then you got a Ferris wheel. And the Ferris wheel goes above ground, and the Ferris wheel goes below ground, right? Which way do we go? Clockwise or counterclockwise? Counterclockwise. So we're going this way right here. So now look over here. As we go along, these are, it says position of the rider, angle, measure, and standard position in degrees. So this is how many degrees you are. This is how high above or below the ground you are. So let's go to one that's not so easy to graph. 45 degrees. How high up are we? At 45. Can you find 45 on here? It's halfway between 0 and 90, so it'll be right about here. It looks to me like right at there, it looks like if we drew a line straight across, halfway up and halfway over, it'd be right about there, wouldn't it? So if you're right here on the Ferris wheel, you're going to be right here. What about when you get all the way over to 90 degrees? Oh, I put that in the wrong spot, didn't I? I have it a little too far over. Yuck. Anyway, let's do an easy one like 90. When you get to 90 degrees, how high up are you? How high is this? Well, it said it had a radius of 50, or I'm sorry, a diameter of 50. So on the graph, how high is that? What's half of 50? 25. So go to 90 and put a dot at 25. Yours is going to look better than mine already because I already messed up this point and I used a pen. That was my mistake. All right, let's do this easy so even Mr. File can handle it. All right, you go up. By the way, you're going up. You're a little kid. What's happening here? You're getting scared, right? Now you are at your most scared right here. And then what happens? You start to come down until what happens at how many degrees am I pointing at? Not 0 degrees. 180 degrees. Now at 180 degrees, how high off the ground are you? Ground level. 0. Now keep going. Now you're down below ground, and they probably have all kinds of scary things, to look at as you're going underground, right? If this was like Universal Studios or someplace where you ever been on one of those roller coasters where it goes up and then it goes below ground for a little while? Don't they have something scary going on under the ground as you're going through? Dollywood, they have something like that, right? So let's say our Ferris wheel, we're looking at all kinds of ghosts and goblins here. How low are we getting at 270 degrees? We're down here to where? Negative 25. So go down here to net 270, go down to negative 25 and put a dot. Then what's happening? Then you see more ghosts and goblins, but where are you going? Back up. And that goes all the way to how many degrees? 360. Now stop right there. we've graphed a bunch of points. Let's see if you can use your artistic ability now to figure out what's going on. You're starting here and you're going up and you're going down. And then you're going up. So connect the dots kind of like I did. How come you don't want to make your graph look like this? What's wrong with the way I connected the dots there? When you get to the top, do you immediately like hit a brick wall and start going down? No, you slow down and then you go back down. Think about the pendulum. When the pendulum was going back and forth, did it go the same speed the whole time? No, it's going fast at the bottom. And then when it gets up here, what starts to happen? It slows down and eventually it slows down so much that it stops. And then it starts going the other direction slowly at first and then faster. And then gravity brings it all the way down here. It's going fast at this part. And then up here, it's starting to slow down. And eventually it stops again. So when you're doing these, you don't want any sharp edges. You want it to be kind of rounded off like that. Now, what's happening then? What happens? How many degrees? How many degrees? 90. What's 90 degrees more than 360? 450. So go back up to 25 and put a dot. Then go to 540, put a dot. Go down to 360, put a dot. Go over to 720. Isn't 720 2 revolutions, right? So connect the dots. Try to be smooth. Connect the dots nice and smooth. You think you got it? Think you know what you're doing? Keep on going. Keep on going. Let's see. They've got them marked for you every 90, so that makes it kind of easier. So at 810, 900, 990, 1080. Now it said we were going to do this for 4 rotations. How many rotations have I got graphed so far? 3. I need one more. So I got to go 1170 and 0. Let's see down there. If you've done a good job of graphing this, all of those should look the same. So our underground Ferris wheel, should I keep going after this? Should I keep going up? No. Why not? It said it was only, what happens after 4 rotations? You're done. You stop, you get off, next group gets on. So you'd have to stop at this point, right? So it only said 4 rotations. So on a test, this is what I would do. I would give you this graph and I would say, here's a graph of the underground Ferris wheel. Tell me, what is the period? This would be a good test question. Now remember, what does period mean? Period means the length of the smallest interval over which the function repeats. What is the length of the smallest interval over which this function repeats? The length of the smallest interval over which the function repeats. How many times did our function repeat here? 4. So how long is it for 1? That's what they're asking. What is the period? The period is from here to where? Where does it get back to there again? 360. So to right there, from there to there, from there to there, that is the period. The period is from 0 to 360, or from 360 to 720, or from 720 to 1080, and so on and so on. How far is the period? 360 degrees. That's exactly right. What is the amplitude? Now, it says here that the amplitude is half of the absolute value of the distance between the minimum and the maximum. Okay, what's the minimum? You don't have to write this down, but you just tell me what's the minimum. What's the smallest value that we ever get to on this roller coaster? No, not roller coaster, Ferris wheel. Not 0. We go lower than 0. Negative 25. What is the maximum we ever get to on this Ferris wheel? Positive 25. half of the absolute value of the difference. Difference, what does difference mean? Plus or minus? Minus. What is 25 minus negative 25? That's 25 minus 25. What's 25 minus negative 25? 50, right? Because it'd be like plus. So what's half of 50? 25. 25 feet. Oh, yeah, sorry about that. So the amplitude is this distance. It's like from here to there. Right there. That's the amplitude. That's the amplitude. Or you could say from there to there. It doesn't have to be on the positive side. The amplitude is just the distance from there to there. And what is the midline? The y equals what? What line is halfway between? Well, what was the midline? The midline, it says here, is the average of the minimum and the maximum. So if the minimum is negative 25 and the maximum is positive 25, then where's the midline? Y equals what? 0. 0 is halfway between. And isn't that the line that goes right down the middle? That's it. All right. Turn to page 19. M419. M419. These are also excellent questions that you will most likely see on a test at some point. Fill in the blank. Let's do these together. The terminal ray of an angle in standard position is the ray with its endpoint at the origin that is not the what? What's the other ray besides the terminal ray? Initial ray, write that down. That's the initial ray. So the terminal ray and the initial ray are totally different. The initial ray is on the x-axis, goes to 0 degrees. The terminal ray starts at the endpoint of the origin, but it goes somewhere else. Number 2, the blank of a periodic function is 1/2 the absolute value, the difference between the maximum and minimum values. What is that? You wrote it down. What is it? Amplitude. Excellent. Amplitude. These would be great test questions. Number 3, an angle is in blank when the vertex is at the origin and one ray of the angle is on the x-axis. We didn't spend as much time talking about this, but what? I'll give you a hint. It's a 2-word answer and the second word is position. What kind of position? What kind of position? Starting position. What kind of position? Standard, thank you. Standard position is looking like this. Standard position. So write that down. That is in standard position. A blank is a function whose values repeat over and over in regular intervals. What kind of function is that? Periodic. Excellent. Periodic. That's just what we're studying today, periodic functions. The blank of a periodic function is a reference line whose equation is the average of the minimum and maximum. Not the 0, the midline. That is the midline. 6, the blank of a periodic function is the length of the smallest interval over which the function repeats. Smallest interval over which the function repeats. For instance, on our first example, the period was 1 year. Ooh, I just gave you the answer. What's the answer? Period. That's the period. And finally, the measure of an angle in standard position is the amount of rotation from the initial ray to the what? Terminal ray. Terminal ray. All right. Awesome. So we're gonna use all this new knowledge that you have to do some actual figuring of some things tomorrow, but for today, there's no assignment, so. That's it. Congratulations. So can you hit the